Dear all, I would like to welcome you all in the lecture series of Basic Electrical Engineering Laboratory. In this video, I am going to discuss important Viva question from the experiment, measurement of single phase power. So in your lab manual, it may be in this fashion, measurement of power consumed by CFL, LED, incandescent lamp, etc. However, the experiment is basically measurement of single phase power. Moving on to the discussion, let us discuss the first question. Define power. How do you calculate single phase power? That would be the first question. What is power? Can you tell me what is power? Power is nothing but the ratio of work to the time. It is a rate of work. Okay, work by time. W by time. Work by time is known as power. What is the unit of power? Generally, what we can say? Watts. Okay, but there are different forms of power that I will be discussing. How do you calculate single phase power? So you can use the formula. Power is equal to general mathematical formula. VI cos phi. It is a general formula to calculate power. If they specifically ask, you can say that this type of power is known as real power. Real or active power. Okay, that point you have to remember. Next, how do you measure single phase power? So you can measure the single phase power by using a wattmeter. Okay, they may ask another question. Next examiner may ask in another question, how do you measure single phase power? At that time, you can say that a power can be measured, single phase power can be measured by using a wattmeter. See, this is your wattmeter. So you can mark the terminal, mains, load, common, voltage. The first part is known as current coil. Okay, as you can see a coil, this is your current coil, where the second coil is known as voltage coil or pressure coil. Voltage coil. You may note down this. The second question is, what is power factor? So there are three definitions. Any definition can be given. Power factor is nothing but, you can mention cos phi. It is denoted by the letter cos phi. It is the cosine angle between voltage and current. That is the first definition. Okay. Another definition, the power factor is the ratio of the real power to the apparent power. Okay, real power to the apparent power. Ratio of real power. So if you draw one power triangle, you can calculate the cos phi like this. So there is a right angle triangle. This is your phi. So you can put the real power base side. This is your reactive power, where hypotenuse should be apparent power. This is called a power triangle. So it is a ratio of real power to the apparent power. Okay, real power to the apparent power. Real power will be depicted by using the letter P. Then apparent power will be represented by the letter S. P by S. You can write it. It is a ratio of P by S. Real power by apparent power. I think it's clear to everyone. If I talk about RLC circuit or RC circuit or RL circuit, what is the general formula of power factor? So power factor can be written as cos phi. Cos phi is nothing but ratio of resistance by impedance. So three definitions are given. Based on the convenience or based on the circumstance, you can apply the definitions. In exams also, based on the questions, you can proceed with this. I think it's clear to everyone. Another one, what is the power factor of resistive load? For power in resistive load, the phase difference, the phase angle difference between voltage and current, that is equal to, there is no phase angle difference. So phase angle difference equal to 0. Phase angle is equal to 0. Therefore, power factor cos phi, that is nothing but cos 0. What is cos 0? Is equal to 1. So power factor of resistive load will be always equal to 1, or you can say it as unity. Unity. Some literature you can see unity also. What is real power? The power which is actually consumed in the circuit is known as real power. So real power can be calculated by using the formula Vi cos phi, real power. Base side, you can see the base side, that is called the real power. What is reactive power? Reactive power is nothing but the power which cannot be consumed, power which flows forth and back, that is known as reactive power. Reactive power cannot be consumed. However, reactive power is required. Okay, so reactive power support in higher classes, you will be learning about reactive. If you are electrical background, you will be learning about reactive power support, reactive power compensation. So it is required also. Okay, reactive power is proportional to voltage, that you will be learning in higher classes. However, reactive power can be calculated by using the formula Vi sin phi. Remember this. This is your reactive power. So what about apparent power? So apparent power is nothing but the product of voltage RMS and current RMS. Generally, we can say. Otherwise, it is a vector sum of real power and reactive power. You can say like apparent power. Combined real power and reactive power is known as apparent power or total power. From the right angle triangle, you can able to write the apparent power. So if you apply the Pythagoras theorem also, you can write S is equal to square root of real power plus reactive power. Like that also you can write. Correct, no? Similarly, apparent power is nothing but VRMS into IRMS. Nothing but we can write V into I. V means VRMS, I is nothing but IRMS. I think it's clear to all. Moving on to the seventh question. So far we have completed the fourth one, fifth and sixth. Now let me discuss about seventh one. What is the power factor of inductive load? See, power factor of inductive load will be always lagging. For example, induction motor. If you talk about induction motor, the power factor of induction motor will be always lagging. Correct, no? Because it's an inductive load. Similarly, what is the power factor of capacitive load? Power factor of capacitive load, power factor will be always leading, because power factor is high in case of capacitive circuit. Because of this fact, power factor can be improved by connecting a capacitor parallel to the load. Okay, there are different methods: static capacitor, then synchronous condenser, phase advancers. There are different methods. Basically, the capacitor, static capacitor, especially static capacitor. You must have heard about capacitor bank near to the substation. Why it is needed? Because capacitor is very useful for improving the power factor. Okay, static capacitor. There are different strategies are available for improving the power factor of certain load. There are different setbacks if you are maintaining less power factor. Hope the session is clear. Now I'm going to discuss remaining part of the session. Okay, let me erase all the segments. So I request everyone to note down these valuable points. I could not explain in depth. However, precisely I could explain, I believe like that. So this will be really useful for your Viva, because I'm explaining only that particular point. I'm not elaborating. So you'll be getting credit for this. Yeah. Now I'm going to discuss the remaining part. Okay. Yeah. What are the terminals of wattmeter? I have already discussed it. Wattmeter is used to measure single phase power. As a wattmeter, mains, then load, common, voltage. These are the four terminals of wattmeter. Here, this is called current coil, and this will be voltage coil or pressure coil. Already discussed it. What do you mean by CFL? CFL is nothing but compact. Full form may be asked. Compact fluorescent lamp. It will be having like two electrodes, correct? There will be two electrodes. Electrode anode, and there is cathode. Voltage is applied between anode and cathode. Then electrons start ejecting in this particular glass plate, which is closed one. And in the outer covering, there is a phosphorus coating in the outer covering. Okay, phosphorus coating. Electrons are colliding with this phosphorus coating and emitting white light. It's a simple working. There are a lot of procedures, but as far as the first year lab exam concerned, that is not so important. You can briefly explain anode, cathode, how the electrons are emitting. Then there is a phosphorus coating. Electrons are colliding with the phosphorus coating and the white light is emitted. Like that you can explain. That is sufficient. What is wattmeter constant? Okay. So wattmeter constant will be represented by the letter K. Okay. So the V range, voltmeter range of the wattmeter need to be calculated. Then I range or I selected, I range into power factor of the wattmeter. They will be mentioning in the meter divided by full scale deflection. Full scale deflection. This is a formula. Everything is available on the wattmeter itself. First of all, you have to take out the wattmeter, whichever you are using. So note down all the parameters. What is V selected or V range? What is I selected or I range? Later, power factor. Then you have to see what is a full scale reflection. Maybe 0 to 600 or maybe 0 to 300. What is the maximum range that you have to identify? So using this formula, you can calculate wattmeter constant. Now, what is the use of this? Suppose you will be getting one reading. Say, you computed the wattmeter constant is equal to 2. Whatever the wattmeter reads, that is 100 watts. What you are supposed to do is the final reading, that is nothing but the measured power into K, that is equal to 100 into 2, that is nothing but 200 watts. This will be the real exact power, real power. I think it's clear to all. So which among the lamp consumes highest power and least power respectively? You know, the incandescent lamp. So here, this is your incandescent lamp. It will be consuming highest power. Highest power. Where LED consumes the least power among this. Least power. The incandescent lamp operates at unity power factor, almost unity power factor. But LED is operating at a lagging power factor. That you can able to verify using the experiment. So what is unity? Very, very important question. I'm talking about unity. See, let me rub the screen so that I can write comfortably. So define unity. So how will you give the answer? It is very essential for basic electrical engineering. Define unity. So what is the importance of unity? So that can be expected. So let me note down. Yes. So unit is nothing but it is a commercial unit. It is a commercial unit of electricity or electrical energy. Electricity. So 1 unit is nothing but 1 kilowatt hour. This is very important concept. In your house, you are receiving electricity bill based on 120 units, 240 units, 250 units, 300 units, etc. So what is the relation between power and energy? Energy is nothing but it is a capacity of doing work, ability to the work. Power is nothing but the rate of work done. That's a major difference. But both are related. See, power is equal to work. Work is nothing but energy. No? Work and energy both are same only. Energy by time. So you can write energy or work. People are getting confusion. Power is nothing but work by time or energy by time. So energy can be written as work, power into time. So this is a relation. This you have to remember. So power is equal to energy by time or energy is equal to power into time. Now another important question. Which among the bulb glows brighter, 100 watts or 60 watts? So you can check the formula. P is equal to V square by R. From this, I will be writing P is inversely proportional to 1 by R. Look at here, as the power is high, the resistance comes down. Correct, no? Here, which bulb is having least resistance? That is, those who are having highest power, that particular bulb is having least resistance. Obviously, the 100-watt bulb is having least resistance. Therefore, 100 watts bulb glows brighter compared to 60 watts bulb. You can explain using this formula. Correct, no? So they may ask in terms of resistance also, which lamp is having highest resistance. So please use this formula. Here you can say that 60 watts lamp is having highest resistance, where 100 watts lamp is having lower resistance compared to 60 watts bulb. Like that you can answer it clearly. Like that you can prepare for your the basic questions. Let me know if you are having any further queries. You can put in the comment box. No need to elaborate. So please come to the point. Okay. So that is the thing which the examiner is expecting. So thank you for watching this video. I need your valuable comments. In the coming video, I'm going to discuss most important Viva questions based on experiment number 4. So thank you for watching this video.